Okay, so hello everybody. So I'm Guillaume Garzon. I work at CNRS. It's a French research laboratory in Toulouse. So what we've been working on is OM2M. It's an open source project for horizontal interoperability in IoT. So that's what I will talk about today. And here you have a small sample of our team, which is compound about full members, which are researchers and teachers in Toulouse, and also PhD students like me. So first of all, what is OM2M? So OM2M is a platform which is compliant with a standard. That is to say that the APIs of the platform are standardized, so you have interoperability between the systems and between the nodes of the system. So first we were compliant with the Smart M2M standard, which were developed by ETSI, the European Standard Institute. And now from November in last year, we are now compliant with the oneM2M standard, which is more international. I will talk about later. So OM2M is based on a RESTful API and REST architecture. So it offers a generic set of capabilities and resources based on the standard. It's also based on an OSGI architecture. So it's really extensible and really easy to extend and to improve with plugin architecture. And it's really a tool to deploy a solution for IoT independently of the underlying network or technologies. So the main features are, for instance, machine registration, application deployment, etc. But an important point is that we are an open source project hosted by the Eclipse Foundation. So we are part of the IoT working group on the Eclipse Foundation. And you can find our project in the Eclipse repositories. So we deployed this architecture in our laboratory in a smart building, which is a dream building. It's where we have a lot of sensors deployed in the building. We have also solar panels to work on energy regulation, etc. And also we use the platform in a mock-up of the building for demonstrations. Also, there are some commercial uses of OM2M by partners, such as e-devices, for instance. And we have a huge user and developer community that is still increasing regarding to the previous standard and now with oneM2M. And we work with the platform in European and national projects as a research point of view, but also with industrials and summer school, for instance, in Toulouse or somewhere else in the world. And the platform has already been extended by several organizations for their personal use and needs. So a short history of the system. First, we started the initial contribution in 2013, the first publication on the Eclipse Foundation. And we've made the first release, or official release, in April 2015, which were about the Smart M2M standard, the European one, with some features and protocol bindings. That is to say that you are able to communicate with the platform in HTTP or in CoAP. Since the end of last year, we now work with the oneM2M standard, and we are waiting really soon on the new release of the platform. But the source code is already available on the repositories. So the interest for the project is worldwide. Of course, it's a bit better one in France, but also in Asia and America. And we are different contributors and committers on the project. So François and I are the direct committers who worked on the new version of the platform. And also there are some contributors such as Orange or Sierra Wireless that are working with us to improve the system and to contribute to, for instance, with an OSGI expertise to be able to change the OSGI framework, or from expertise for device management, for instance. Here you are a little excerpt of our contributors, users, and interested parties. And for instance, I can talk about eDevice, which is working with eHealth solutions using oneM2M. So the roadmap for the project is to improve the actual version and provide new communication bindings, such as co-op, and of course integrate the new fixes and features of the standard. So really soon we will participate in a plug test in Korea about the last version of the release 1 of the standard, and by the end of the year the release 2 will be available, and we'll have to work to integrate those new features in the platform. And also we worked on research aspects such as semantic aspects or autonomic computing to integrate semantic interoperability between the data in the platform, and not just horizontal interoperability between the systems. So concretely, how is the system deployed? You will have a field of devices you can meet in the IoT context, and they will be communicating with our platform through different protocols and proprietary protocols sometimes. And the idea is to make this abstraction of those protocols to have standardized APIs at the high level, which will be available in HTTP or co-op, for instance. And the power of this architecture is you can work as a developer for a mobile application, for instance, and you can develop your application without knowing the architecture of our system. If you know the standard, you can work with our platform or another one, which can provide an API, standardized API. So now, talking about the software architecture of oneM2M. So we are based on an OSGI framework. That is to say that we work with Java language, and we have a set of plugins that will be deployed and instantiated with corresponding to the need of the node where we will execute the platform. For instance, we have a core plugin that is basically running the main features of the platform, and what we can do is start the plugins you need. For instance, in the server side, we will have the communication binding protocols, HTTP, and we will have some plugins able to serialize the content of the request when you are asking the APIs. And in a lower level, you can have some plugins called interworking proxies that will make the job to translate the proprietary protocol of the devices to the standard representation. So now, regarding to the standard, there are a lot of standards organizations in the world, and particularly for IoT. There are a lot of entities, alliances, and standardization organizations. But oneM2M is one of the most global standard organization. It regroups over 200 members organizations with standardizations such as ATIS or ETSI in America, in Europe, and in Asia with China and Japan, and other standard organizations for device management, for instance, such as OMA. And the idea of oneM2M is really to to have a close interaction with companies that are working on solutions and standard institutes that will work on the abstraction layer. So the organization of oneM2M is separated in different working groups that will work on different aspects, such as the architecture of the standard or the protocols you will be able to communicate with, and also, for instance, in the mass group in management, abstraction, and semantics, that are working on the interoperability of data. So the architecture of the standard is based on different types of nodes. So you can have what they call an infrastructure node, that is the higher level node. Typically it will be the server or the cloud hosting your solution. And below this node you will have other nodes, such as middle nodes, that will be gateways or intermediary servers that will be communicating to the infrastructure node and also to other nodes or devices in the lower layer. And here you have a sample of an architecture with an infrastructure node on the right that is able to communicate with another infrastructure node in another company of another solution, thanks to the standard. And on the left you have other nodes which are composing the topology of your network with middle nodes, and here you have an application service node which is more dedicated, for instance, with a smartphone that will interact with the system. The idea of oneM2M is to specify entities and resources that will make the abstraction of the protocols and will be able to structure the data. And here you have some application entities that will represent the applications that are connected to the system. You have the CSE, the Common Services Entities, that are hosted in the nodes that will expose services to the applications, for instance. And you have also the network layer that is in charge of the communication between the nodes. So here, a little insight. In the infrastructure node, you have different kind of services that can be deployed, and of course, for instance, you will have an instance. You have oneM2M that will be running on this node, on the server. But the idea is not to have all the reasonment on this machine, and you have also typically gateways that will be considered as middle nodes in the standard, that will be interacting with the infrastructure node, and where you can also run the oneM2M platform. And those gateways will interact with devices, and also you have other systems that have enough power to interact with middle nodes or with the infrastructure node, that will be able to exchange data with the standard APIs. And here you have, for instance, a device that is smart enough to send HTTP requests that will interact with the system, and you have also nodes or devices that are not smart enough to interact in oneM2M, and that will be connected to a gateway. So the services functions are really heterogeneous, and there is a lot of them. But for instance, you are able to discover the resources. There is also security issues with access rights management, so who can access to which resource. And you have also a mechanism of subscription and notification in the system. And I will show you an example of this. And here there are some of the main resources of the standard. I will not go into details on all of them, but for instance, you have the CSE based resource that represents the CSE where the system is executed, the node typically. And you have, as I said, the application entities that will represent remote or local application. It's really interesting because you can have a remote application that will register in the system, and so you will see this application as an application entity, but it's not hosted in the node, it's a remote. And you have other resources to structure the data, such as containers and content instances, which are really the instances of data your sensors are pushing in the system, for instance. And you have other resources to handle different aspects. So here I will show you a little example of a resource tree and a subscription mechanism. So here you have the IN CSE, which is the server or a cloud entity, which is the top level of your system. And you have on the right an end user application that will run on a smartphone and that will be able to communicate with your system. And you have some gateways in the environment that are deployed and that will interact with the server. And you have in the end a smart meter that will be connected to a gateway, and you will be able to retrieve the power consumption in your smart meter, for instance. So here you have the base resources. We have the server on the right and the gateway on the left. And first of all, the gateway will register to the server. So the idea is in both sides, you will have resources representing the other node. So you will be able to communicate with him, because you will not have all the power and all the data in the server. You have the topology is really it's a huge topology, and you have some power in the gateways sometimes. So first the gateway registers, then you can register your smart meter in the gateway. So you have here an example with an application that will represent your device, and then some containers that will allow to structure the data that will be stored in the gateway. So now that everything is registered, you have the smart meter that pushes a new value. So you have here a content instance that is created in the gateway. And the idea is now with my application, I want to know my consumption, so I want to access to this data. So of course the server is able to communicate with the gateway, and the administrator of the system will be able to retrieve the data. But as a user, how it can happen? First, the application will register to the server, because it's the only access point from the outside of the system. But then it will create a subscription directly in the gateway for the data consumption. So this means that the application will get information directly from the gateway and not from the server, even if the server is just routing requests. So here you have now a user subscription that is created in the gateway, and when the smart meter pushes a new value, it will trigger the subscription, and then the gateway will send a request to the IN, and it will be redirected to your application. So you can be notified of a new instance of consumption. So here it's just a little sample of a oneM2M architecture and how it can be run. So regarding to our project, you have a lot of web resources, so don't hesitate to go to the oneM2M website. We have a wiki with a lot of tutorials and information about the project and the APIs. And of course you have the oneM2M specification of the standard on their website. And here we have a link of the repository of our source code. So thank you, and if you have any questions.